Springs Institute. And she's going to discuss the challenges facing Florida Springs through the Florida Springs Institute's Blue Water Audit Project. Haley's passion for the springs began on her first visit to the Ichitucky River. Her love of geographic information systems was born during her time at the University of Florida, where she graduated with honors in landscape architecture. After her GIS internship at the Florida Springs Institute, she transitioned into managing FSI's outreach efforts and now manages the overall direction of the Institute. And her dedication to the Springs continues to grow as she focuses on communicating the challenges that face the Floridan. So please welcome Haley.
Thank you so much, Jody. Thank you for inviting me to speak to your group today. My name is Haley Moody. I am the director of the Florida Springs Institute in High Springs, Florida. And I'm gonna talk to you today about the springs and also some programs that we have developed and how native plants can help the springs. So I'd like to start just by showing you all a short video that we developed. It's about a 3-minute video, and you might recognize the narrator, but I'll just go ahead and play.
Florida's ancient living web of blue waters and green vegetation rests on limestone formed millions of years ago. When prehistoric sea levels receded, rainwater dissolved and filled the voids in this limestone, creating the Floridan Aquifer. Florida's springs and rivers ecosystem has drawn life from this aquifer for 30 million years. When humans first inhabited this primal landscape of virgin forests, sparkling waters, and fierce megafauna, they relied on these freshwater springs and rivers to survive. Today, Florida's natural waters provide fundamental life support for both nature and humanity. Florida has the largest concentration of free-flowing springs and spring-fed rivers in the world. Ecologically diverse plant and animal communities depend on this clear fresh water for survival. Culturally, these springs are important places for contemplation, recreation, and discovery. Economically, springs generate over $1 billion of direct income for communities each year. But the well-being of America's largest concentration of natural springs is threatened by habitat degradation, intensive development, and water pollution. The Florida Springs region covers the northern half of the state and includes more than 1,000 free-flowing springs. During periods of drought, these large springs supply essential fresh water needed by iconic rivers, such as the Apalachicola, the Suwannee, and the St. Johns. Florida is awakening to how much of its inherent beauty has already been lost to development. Citizens overwhelmingly support the conservation of large areas of interconnected natural lands. Now it's time for all Americans to learn about and experience the wonder of America's largest region of natural springs. When this happens, we will ensure the survival of America's ancient, majestic, and life-giving springs and spring-fed rivers for future generations.
That was narrated by your Coyote. And give me just a second here. Oops, sorry about this. Okay. I am sorry about this. I think gotta get back to the I'm not sure what happened there. Sorry guys, give me just a second. I'm not sure out of that. I'm sorry, I'm not sure how this happened. I will. Okay. Let's see. Okay, so I'm very sorry about this.
Yeah, you can stop sharing and open your PowerPoint and then you share.
I think it's because it took me out of my presentation and into YouTube that we're having this issue. So. Okay, that should do it. I'm so sorry. I am actually borrowing this computer, so it's not the one I normally use. And so to get back to sharing for everyone, I go to the Zoom and share screen. Chrome tab. Okay, so I hope you guys can hear and see us now. Okay, sorry about that. So that is the QR code for that video that you just watched. We created that in order to try to gain some national recognition for the springs. There are a lot of people in Florida that know about the springs, but we have a lot of people visiting and moving to the state every day that don't know anything about the springs. So we're trying to get the word out there. Okay, so in this presentation, I'm first going to talk about the Florida Springs Institute, and then I'm going to talk about the Floridan Aquifer, just to make sure we're all on the same page and understand what an aquifer is and how it functions. Then I'll talk to you about the springs, and then the problems that the springs are facing, and then some of the solutions as we see it. So first, about FSI. So we are a 501c3 nonprofit organization. We're located in High Springs, Florida, which is also known as the Florida Springs Heartland, because of the concentration of first magnitude springs that are surrounding High Springs. It is known as the largest concentration of first magnitude springs in the world, and that has not been disputed yet. So the mission of the Florida Springs Institute is to advance the stewardship, conservation, and restoration of Florida's freshwater springs and aquifers through sound science and education. So we have a science arm and we have an education arm. These are some images of our most recent turtle survey on Silver Springs, the Silver Springs system. Our founder, Dr. Robert Knight, is in blue there. Our aquatic ecologist, Bill Hawthorne, on the right. And this is a team of turtle scientists and experts that counted and collected and pit tagged turtles on the Silver River. This is the type of work we do, monitoring and collecting data, and it's just it's an incredible experience. You can see this guy's trying to get away. But this is what this looks like. There's basically a team of scientists, turtle experts, swimming down the river like this and collecting the turtles that they find. They bring them over to the boats, and they end up scanning them for a pit tag. If they don't have a pit tag, they will give them one, and then they get measured in all kinds of ways. And this data is uploaded to a very large database. So that's the type of thing we do. These are some of our programs. We have Springs Academy, which is a monthly lecture series. So there's about 6 topics that we run through, and a Springs expert will come up to our environmental center in High Springs and give a lecture about the springs. Topics like biology, chemistry, hydrogeology. On the right here, those 2 images are from our Springs Field School. It's our most comprehensive sort of education program. Attendees will spend an entire week listening to lectures through Zoom every day. And then at the end of the week, we have a big paddle out on the Itchtucknee River and a celebration at Poe Springs. It's really a lot of fun, and people just attend this program and then they just continue to be involved with us. So they really love it. Down at the bottom, that's our annual Springs Run. We host that with First Magnitude Brewing Company in Gainesville. It's our largest fundraiser. We have about 700 runners that come out every year, and raise money for the springs. So Springs Watch is our citizen science program. We have about 150 volunteers going out every month to monitor water quality and water quantity at 11 different spring systems across the state. So this is an incredible program. If anyone is interested, you can find all the information on our website and what group you might want to sign up for. I just highly recommend it. It's an incredible program. Some of these systems we've been monitoring for 14 years now. So, and then we also have our field science internships. So 3 times a year we take on interns, and they help us with the water quality monitoring. Okay, we also have the Florida Springs Welcome Center. So this is a relatively new building to us. We moved in 2 years ago, and we have just officially, as of last week, raised enough money to purchase this building for ourselves. So we're very excited about that. And this will be the permanent home of the Florida Springs Institute. But we have, you can see a manatee skeleton there in the window. We have a museum side of the building with museum exhibits. We have a mastodon jaw replica. We have a fully articulated manatee skeleton. There's all kinds of fossils and artifacts from the Santa Fe River. All kinds of things to come and see and learn about the springs. We also have a springs store with springs related gifts. So we're open every day of the week. So come see us. All right, now let's dive into this. The Floridan Aquifer. So, is everyone familiar with what an aquifer is? Maybe. Some of you, maybe. Not sure. Okay, so an aquifer is a body of permeable rock that can contain or transmit groundwater. So that's all to say that we are basically standing on top of our drinking water in Florida. It's really held underneath us. And the aquifer gets filled with rain. That's really the only way that water is making its way into our groundwater is from rain percolating down through our sandy soils. So over 90% of Florida's drinking water comes from our groundwater, stored under our feet. And this is the same source of water that discharges from our springs. So if you live in Florida, chances are real good that you're flushing your toilet with what would be spring water. And that's the same water you're watering your lawn with, pressure washing your deck, all kinds of things. It's the same water that would be coming out of our springs otherwise. So the Floridan aquifer is enormous. It's over 100,000 square miles. It covers the entire state of Florida and goes into 4 other states, South Carolina, Alabama, Georgia, and just a little bit into Mississippi. That is a map of the Floridan aquifer. It includes everything except for the small piece going into Mississippi. And this is a diagram attempting to explain the function of the aquifer. So you can see here that rainwater is coming down. That's really the only way it gets filled up. And the only place that rainwater can recharge the aquifer, it's called recharging the aquifer. The only place that that can happen is when there isn't a confining layer. Okay, this is something that I will come back to later in the presentation. But if you see here this layer that's labeled clay, so that acts as a confining layer in our aquifer. Because the particles are so finely consolidated, they don't really let water percolate past very easily. So where there's a confining layer, it makes it harder for recharge to happen, but it also makes it harder for any contaminants that are picked up on the surface to get into our groundwater. So I will come back to that. But for now, this model is now in the Florida Museum of Natural History, and you can see it there. It's part of their Water Shapes Florida exhibit. That is an image of what it looks like in our aquifer. It's pretty incredible. Most of the images in this presentation are by John Moran. Okay, so that brings us to springs. So springs are where that groundwater in the aquifer, when it's under pressure, if there's an opening in the land surface, water will be forced out through pressure. And that's what a spring is. That's all a spring is. If there isn't that pressure, it's nothing more than a sinkhole if water's not coming out of it. So there are 1,113 documented springs across the state of Florida. That's by the Florida Department of Environmental Protection. When I started working at the Florida Springs Institute, I think there were just under 1,000. So they're finding new ones all the time. Springs are categorized by how much of that groundwater is discharging out of the opening. So there are 33 first magnitude springs across the state of Florida, and those are discharging more than 65 million gallons per day. So quite a bit of water. Springs have a bad rap for being cold, and they are cold, but they're 72 degrees Fahrenheit is their average temperature. But something to understand about springs is that the average temperature of the spring is really dependent on the ambient temperature. So springs in North Florida are a little bit colder than springs a little further south, only by a few degrees, but the 72 is the average of all of them. This is an image of Little River Springs on the Suwannee River. It's pretty iconic to see where that crystal clear water meets the tannic river water. And of course, humans are not the only ones that enjoy springs. Because of their relatively constant temperature and clarity, there is just an abundance of wildlife that depend on these systems. All right, now we're going to get into the problems. So there are 2 major threats to the health of Florida springs: groundwater withdrawals and nitrogen pollution. So how I'm going to talk to you guys about those problems is through the Florida Springs Institute's Blue Water Audit Project. So this was a multi-year project, and it was conceptualized by a GIS analyst at the Florida Springs Institute named Angeline Meeks. who is an incredible person and has an incredible brain. But basically through the Blue Water Audit Project, what we did is we analyzed 27 million acres of the Florida Springs region. Okay, so the Florida Springs region is the area in Florida where springs exist. It's everywhere north of Lake Okeechobee, essentially. So the northern 2/3 of the state. And we looked at every parcel of land in that 27 million acres and assigned it a Floridan aquifer groundwater withdrawal footprint and a nitrogen footprint, every parcel. So first, I'm going to talk to you guys about the nitrogen. So this is an image of a spring. This is pretty typical of a spring that's been impacted by nitrates. You see this filamentous algae come in and take over everything. It'll suck up all the oxygen and doesn't really let anything else live or grow in there. So if you see this, you know that nitrates are a problem here. And that is West Giles Peacock Springs State Park. All right, so before I get too far into this, I like to have everybody just take a deep breath in. Okay, breathe out. Now, 78% of what you just inhaled is nitrogen. Nitrogen is present in all living things. It's considered a building block of our DNA. Life could not exist without it. It gets a really bad rap when we get into this area talking about pollution, but it's really important and it's all around us and we couldn't survive without it. So we need to know that. It's just the problem comes in when we start loading our systems down with more than they can handle and they can't recover. So again, I'm going to go back to that idea of aquifer confinement and a confining layer, a layer of sediment or rock that has low or no permeability. It doesn't let water percolate past it. You can imagine it like a sheet of plastic, somebody throwing a sheet of plastic down. So in this map, you can see that the blue area is where the Floridan aquifer is unconfined. That means there is no sheet of plastic, there is no clay layer, there's nothing stopping anything from the land surface from getting into our groundwater. It's direct, pretty much a direct route. So the light gray is the area in Florida that is thinly confined, and then the darker gray is where there's a pretty sturdy confining layer. So you can see up here in Jacksonville, we're sitting on top of a nice thick confining layer. And you'll see how that plays out with the footprints for the Blue Water Audit Project. So this is the Blue Water Audit Floridan Aquifer Nitrogen Footprint for the Florida Springs region. The darker colors are where nitrates are having more of an impact. And the lighter colors are where they're having less of an impact or no impact. And you can see Jacksonville, there's not much of an impact there because of that confining layer. We're also in a discharge area with the St. Johns River. So that's part of it too. So that's what nitrate looks like across the state. Sources of nitrate nitrogen pollution include fertilizer applications, agricultural, residential, and commercial. By and large, it has been well documented that agricultural pollution is the primary source of nitrate pollution for our groundwater. Human wastewater also is a big player in septic tanks, old and leaking septic tanks, and also livestock waste. So we're just going to take a quick look at aquifer confinement and agricultural land use, because by and large that is the largest polluter. So again, this map was made just a little bit differently. So you'll kind of have to switch the colors in your brain. Sorry about that. In this map, the aquifer is more vulnerable in the darker area. So that is where the aquifer is unconfined. And you can see all the springs there. And this is where ag lands are. So it's not a mystery. It's not a mystery. These are a bunch of Florida springs written way too small for any of you to see. This is where nitrates are across many of our Florida springs. The Florida Department of Environmental Protection established the numeric standard for 0.35 milligrams per liter of nitrates in a healthy spring. So anything above 0.35 is considered an impaired spring. And you can see most of them are above that. And this data actually only goes up through 2010. So most of the ones that were below that standard are now above it. It's getting pretty bad out there. So we will move on to groundwater withdrawals. And the impacts to the Floridan aquifer when we take too much water out of it. So in this diagram, you can see sort of some of the impacts of taking too much water. We have reduced spring flows. There's not as much water available to discharge at our springs. But our springs feed our rivers. So when there's reduced spring flows, there's also reduced river flows. Public supply wells, if you get your water from a public utility, typically those wells are deeper than private home wells. And so your self-supplied home well will go dry first. This is a breakdown of how water is used across Florida. This comes from the latest USGS report. And you can see by and large, public supply is the biggest consumer of groundwater. The scary part of this diagram is that in the public supply category, it's estimated that 60% of that water use, of that 1.17 billion gallons per day, is being used for outdoor irrigation. All right, so this is what the groundwater withdrawal footprint looks like across the Florida Springs region. All of a sudden, Jacksonville's showing up again. You can see it. And mostly this is where the populations are. So you can see sort of the big cities standing out. But there are also spots on this map that are industry. So a single phosphate mine will show up here just like it's a city. Okay, with that groundwater withdrawal from the public supply category, this is what that looks like over time, the trend over time. And you can see in 2000 it starts to go down a little bit. And USGS attributes this to water-saving technology implemented at the public utility level, all the way down to people buying water-wise appliances for their homes. So these things really do make a difference. I'm just going to tell you a couple of stories here about the impacts to the Floridan aquifer from too much groundwater withdrawal. In 2010, Plant City, some of you may remember this, had a hard freeze that lasted for 11 days. And that is actually the area of Florida where a lot of our strawberries are grown. So the Water Management District, during this hard freeze, gave the strawberry farmers permission to irrigate their crops day and night. And during that period, the aquifer level dropped 60 feet. And the area was impacted by approximately 110 sinkholes. And the Water Management District logged nearly 750 complaints of dry wells. So those are people's personal wells at their homes that go dry when this happens. So we can't do it. It's devastating to communities. We have to really watch this. Okay, another thing, at the turn of the century in North Florida, the town of White Springs. It was known as Florida's first tourist destination with white sulfur springs. They had this incredible spring house built right on the Swanee River, and you can see people came from all over to come bathe in the healing waters of this place. So this was at the turn of the century. The spring house. And this is unfortunately what it looks like today. This was captured actually in 2012 during a drought by John Moran, but the spring has not recovered. So you can see in the background there, that's the Swanee River in the background. And so today what's happening is when the river level is up, the river is coming into the spring house, and the spring is actually doing a flow reversal. So rather than discharging groundwater, it is sucking river water down into our groundwater, our drinking water. And this is actually not uncommon. So, solutions. Let's talk about solutions. So, just sort of big picture overview of a solution that the Florida Springs Institute has put out for probably 14 years now is a cap and a fee on both groundwater withdrawals and on fertilizers. So at some point, we would like the water management districts to say, we will not issue another permit because we're already taking too much. We also don't pay for water here in Florida. I know everybody probably has a water bill and it's like, what are you talking about? Of course we pay for water. But you're paying your utility company to bring the water to your house and to take it away and to clean it. You're not actually paying for the water itself. So that's something that not everybody realizes. So we think we should be charged for water. And the same with fertilizer. All fertilizer purchases should be tracked, and an aquifer protection fee should be charged based on the pounds of nitrogen applied. And then a cap should be placed on how much fertilizer can be sold in our state. Yeah, it's a hard line, but it's what it will take. So what can you do? You can inform yourselves, which is what you're doing right now, so thank you. You can capture and reuse domestic graywater, also rainwater capture for appropriate uses. There are a million ways to save water. Taking shorter showers is just one of them, but once you start thinking about this, how can I save water? You will come up with all kinds of ways that you can do it. I also ask you to consider a springs-friendly yard. So I have developed a springs-friendly yard program through the Florida Springs Institute. It's got a little handbook, and we've got a yard sign that you can put in your yard to let everybody know. So a springs-friendly yard, there is no groundwater withdrawal for a springs-friendly yard. There is also no fertilizer application. So I am speaking to the right people because I know all of you know exactly how you're going to achieve that. You're going to achieve it with native plants. That's how you're going to do it. So that's what the program promotes. And of course, attend public meetings, join springs conservation and advocacy organizations, and my goodness, vote like your water depends on it, because it absolutely does. These are some images of the springs-friendly yard. And that is what I have for you today. So, thank you. And please let me know if you have any questions. Yes?
Yeah, 2 questions to give like examples that you've shown. Like the city that's in the Tampa area.
Yeah.
They have a ton of sinkholes there. That's all attributed from that water usage?
That was because all of those sinkholes happened in that 10-day period when the aquifer level dropped. So this is a type of sinkhole. It's called a cover collapse sinkhole. So it's basically like, I mean, you saw that the aquifer model, if you could just imagine like a thin layer of land, and it's really water that's holding it up. So when that water drops, that thin layer of land is just going to drop right with it. So all of those were attributed to that that instance.
And then to the bathhouse, like that, you said it's a reverse flow. When that river water goes in there, is that bad for the aquifer?
It is. Yeah, it sure is. Surface water has all kinds of contaminants, and it's not with that direct conduit. It doesn't have time to get filtered through plants or anything else. It's just going directly in there. So, yeah. Yes.
Do we still have water companies coming into the springs and taking spring water out? So.
We do. We do. And that's part of wanting people to pay for water. I think it makes it very attractive for companies to come and bottle the spring water because they pay for the permit and they pay for the well. But beyond that, they're not paying for the water. Yeah.
Is there a way to find out what companies do that so that we can boycott them?
Yes. Yes, there sure is.
Just go look at the water.
And it tells you on the back which spring it was typically bottled at.
Probably all of them, but just some.
So we've had a circumstance pretty recently at Jenny Springs, which is near High Springs where I work. And Nestle was the company that came in, but I believe they have changed their name to Blue Triton now. So, yes.
Does that permit use go into the audit, or is it the river, the water management district? Is that like a part of their auditing system, like where there's like the cap and fee things does that permit apply to that?
I'm not sure I totally understand the question.
So you were saying how there's like a cap and fee now?
That is what we are proposing.
Oh,
That is one of the solutions that we would,
That's not a legal thing, that's a proposal.
that is a proposal. That is something we would love to see happen. Yep. Yes.
So you're tracking the nitrates. Is the phosphate like similar? Is it a different trend? I know they kind of cause the same thing. The most right? Like algal blooms.
So phosphate actually does not have the same impact to the springs that nitrates does. It's really the nitrates that we're battling. Yeah.
So there's a Florida friendly program that garden program that IFAS has. The extension. Do you coordinate with them? Because it seems like it's very, very closely related to that.
Sure. Yes, we have been in touch. I would say that the Florida Friendly program does allow for fertilizers. And so this is where we've kind of taken a hard stand on that and just said, no, don't do it. Yeah.
We should talk to them.
Yes. Yep.
Sorry. Are there programs that like would help agriculture move away from either like an incentive? We've got like a fee to like reduce that, but also maybe an incentive, you know, help them use less and maybe plant a cover crop. You know.
Yes. So let's see. How can I? So there are 30 springs that are actually legally protected through the Florida Springs and Aquifer Protection Act that was passed in 2016. So through that act, there are 30 outstanding Florida springs that have been designated that now have legal protections. So if their nitrate levels go above that 0.35 milligrams per liter, they go into what's called a basin management action plan, which means that the state And the stakeholders within that basin have to take action in order to bring the nitrates down to 0.35. And they have to do that within 20 years. So a lot of these springs are going through their BMAP right now, Basin Management Action Plan, BMAP for short. And those plans are being figured out, and stakeholders are being named, like cities, counties, that are responsible for implementing projects that bring those nitrate levels down. I think I might have forgotten where. Yes, so, okay, agriculture. Yes, as part of that, as part of the Basin Management Action Plan, farmers do have best management practices that they are encouraged to implement. And as far as the state goes, that's what we're looking at. So we are doing what we can to be part of the BMAP development and to be part of the projects to help clean up the nitrates. Yeah.
Does that include any of the shoreline around the springs? I mean, like plants that are there?
It could, it potentially could. So the stakeholders that are involved, they basically have to find projects that will help. And I could see native planting certainly potentially helping, especially replacing something like sod. Yes. Yes.
Since the Florida Aquifer goes into South Carolina, Georgia, Alabama, it's all connected.
Yep.
And you guys did a great job at doing the nitrate map for the state of Florida. Does anyone know what it looks like for those other states?
So we really just focused on Florida. Yes, it is something that we have been considering and thinking about, is like expanding into those states and doing more analysis. But we just stuck to Florida for now.
Yeah. And is there any organization that represents all of the states that, you know, cover the aquifer? You know, like the Southeastern Spring Alliance or something?
There's not that I know of. Great idea.
And is there and is there a correlation between the point source of the nitrogen pollution versus how far it has to go in the aquifer to be released in spring? I mean, if you had, you know, a cow farm in a spring, you know, 500 yards away, is that better or worse than the one that's far away, or is it all just mixed underground?
It's an excellent question. The difficulty with that question is that every single spring is so different. You know, it's what is going on underground and where that water is coming from and the channel that it's following to get there it's really complicated. And so unless there have been dye trace studies at that specific spring, there's a chance we don't know or don't have that information. So it's a little tricky, but I think the main thing is just they're all really different. So there is, let's see, I mean, there are spring vents that are right near each other, like right next to each other, that they're coming from different sources. So it's, you know, it's, but then there's also examples I can think of. Like we had a project on the Santa Fe River where we had like 63 different sampling sites. And one of the sampling sites was at Troop Spring. And our field team was measuring like 60 milligrams per liter, 60. So if 0.35 is healthy for a spring, and actually 10 milligrams per liter is the human health limit, there were 60 milligrams per liter in this spring. And there was a woman that had, was getting her drinking water directly from the spring that was living right next to her. So our scientists just went and knocked on her door and said, hey, you should not be drinking this water. You need to find another source. So that kind of stuff can happen.
And one other question, does the Florida Springs Institute support the removal of the Rodman Dam to like release those springs that are under that reservoir?
Yes, we sure do. Yeah.
Where is that?
The Rodman Dam on the Aquifer River.
On the way?
Aquifer River. Yeah.
Alex, it's near the Ocala National Forest.
Okay.
Yeah.
Yeah, it's gonna get better
Yeah, how many years have we been fighting
for a long time.
Yeah. Construction stopped, I think, 1969, and I think people have been fighting it ever since. I mean, yes.
So the photo of the spring that you showed, was that, you said it was a filamentous algae?
Mm-hmm.
Can those springs recover if the nutrient loads kind of go down, or do you have to help clean up the algae?
So it's a great question. Springs can recover. Yes, they can. It is a little bit of a combination of both the nitrate reduction, but also the flow is really important. So a reduced flow will cause the filamentous algae to take over in a similar manner to the nitrates. It's like when there's a really strong flow, it's sort of like blowing the algae off the plants. It doesn't let it stick and stay around. But if the flow is reduced, it kind of has that time and it can grab on and start to proliferate. So it's both of those things. It's the nitrates and the flow. We need both of those for springs to recover. But they can. They can. Yes.
Are you seeing any direct effects of the warming climate change in any of your data yet?
So let's see. We have measured an increase in specific conductance in certain springs, which it's possible that is being caused by saltwater intrusion. Yeah, so we are seeing that. There's also an increase in the temperature of the water. So there's that. Okay, any other questions? Yes.
All right, this is kind of really out there, but
I'm ready.
would there ever be a situation where you would like say find an ugly spring and fill it with concrete to stop the flow there to increase the flow in all other springs? So like sacrifice one, take that, 20 million gallons of discharge and push it out to the other ones, like if it's gonna be too close to development or pollution or something like that, can they be capped?
I suppose they could be. I would hesitate. Just instinctually.
I thought it was out there for sure.
Yeah, no. It's, yeah. It does remind me though of something that our founder, Dr. Robert Knight, has observed and documented that like White Sulphur Spring, for example, that stopped flowing. These springs that are higher in elevation, once they stop flowing, the springs that are downstream or like at a little bit of lower elevation will sometimes get a little increase in their flow once one upstream has stopped flowing. But can be temporary until they kind of one by one go. But yeah, so it's kind of a similar idea, but
It's like putting your hand over a jet in a swimming pool,
Right.
You plug one, it gets stronger than the other.
yeah.
And I guess different controversial thing, there's the armored catfish or the placostomus that are infesting a lot of the springs, but they love to eat filamentous algae. So you guys like placostomus and invasive fish or not?
No,
Okay.
no, we don't. So I think I'd have to know more about the eating of the algae. I'd like to learn more about that. But yeah, the armored catfish, they're just pesky. they bug the manatees. They like outcompete other things. It's just, I mean,
Anyone who's ever had an aquarium, you know, has the exact
Yeah.
same nitrate problems you guys have, just on a different.
Yeah.
And that's what the pet shops sell on the big side, so. Not a good idea for springs.
Yeah. Yes.
I just wanted to say, gorgeous map, so love all your maps.
Oh, thank you. That's so nice.
Map appreciated you come.
Yay, that's so nice. I appreciate that. Thank you. All right.
Thank you so much.
Thank you.
Oh, thank you so much.
Yeah, I still think there's some group left. We don't have to do this yet. Socialize some ideas.
Excellent, thank you so much.
All right.
Just
Thank
gonna
you. Yes.
Take us off of the Zoom.
And I will actually put this back in the library if you guys want to take a look at it.